Okay, so before we start today's lesson, I want us to go ahead and imagine and discuss. So here's our problem. The school is a snow cone fundraiser every month called Kona Ice. Currently, Kona Ice is considering changing their cup shape of the King Kona Icy. They plan on keeping the diameter of the opening and the height of the cup the same. But they're changing the actual 3D shape of the cup. As you can see from the old cup and the new cup, they're changing it from a cylinder to a cone. The catch is they also plan on charging the same price. So right now you need to discuss with your partner how you feel about this change and them charging you the same price, and why do you feel that? So go ahead and pause the video and discuss with your partner. So obviously some people are going to be a little upset with this. And just looking at that, you can see that this and this are two different shapes. This is obviously going to hold less in it than the old cup. So this is just a great example of how we visually do volume every day. We can look at these two different cups and see that the one on the left is the better option, especially if you're going to be charged the same price. So if they are charging the same price, we need to think about, what do you think that they should charge for the new cup? It should be a fraction of the original price. So go ahead and discuss with your partner what you think they should charge. Okay, so volume of cylinders, cones, and spheres is what we're looking at today. And our target is I can find the volume of cylinders, cones, and spheres given data and figures. So with your note-taking worksheet, go ahead and take a second to fill out all of these volume equations. Volume equals pi. R is going to stand for radius, which goes halfway through the circle. So pi times radius squared times height. And then the cone is actually 1/3 of the same formula for the cylinder. So in the previous question, if you said that they should have charged you about 1/3 of the price, your guess was right. Because geometrically, a cone's volume is 1/3 of a cylinder's volume. So you would have been getting about 1/3 of the icy. And then we're also going to look at spheres today, and the volume concerning those will be 4/3 times pi times the radius cubed. So our very first example we're going to look at is just a simple cylinder. Whenever you are solving for these formulas, you want to go through and label what you know first. So looking at the 10 inches first, we know that that is our height. Then 3 inches, it only runs halfway through the circle, not all the way across. If it was all the way across, it would be diameter. But in this case, halfway is going to be radius. And then our equation, volume equals pi times radius squared times height. That's the equation that goes with the cylinder. So always write that down first. So that can help you in substituting those values. Speaking of which, that's what we're doing next, substituting in the values. We're going to rewrite it only in place of those variables. Instead of r, we're adding in 3 for the radius. And then instead of h, we're adding in that 10 for the height. Then we're going to go through and solve it just like we would a regular equation. We're going to do our exponents first. 3 squared is 9. So I just rewrote that and brought down pi, brought down 10. And then multiply out the easiest part first. 9 times 10 is 90. So volume equals pi times 90. Then you type that part in your calculator and you're going to get volume equals 282 and 74 inches cubed. Always be sure that whenever you find volume, your units are cubed. So now you're going to take a few seconds, you're going to pause the video and solve this one out on your own. Now that you're finished, your answer should be this: volume equals 1021 and 200 units cubed. Okay, now we're going to do an example of a cone. I've already went through and labeled the height and the radius. But we need to start out once again by writing down the volume equation before moving forward. So volume equals 1/3 times pi times radius squared times height. Once again, we're going to go through and substitute in our values. In this case, our radius is 7, so we'll plug 7 in for the radius, and then our height is 18. So when you rewrite this with the substituted values, it should look like this. Then once again, I'm going to go through and do the exponents first. 7 squared is 49. Then going to type all this in on the calculator and get volume equals 923 and 63 units cubed. Now for another example.